begin somewhere, and a good somewhere is with units, numbers, and scientific notation. So first, units. You've watched videos and you've played with simulations to get a sense of scale. In this course, we'll be looking at objects that are maybe a couple millimeters large, so about the thickness of a coin or two, all the way up to planets and stars, which are the thickness of a whole lot of coins. So we'll need to be able to apply units to our numbers. So a unit is a way of expressing the scale of the quantity you're talking about. If you're looking at the length, you might offer your measurement in centimeters or in miles, or in inches or in light years, so we need to set some criteria for units. So 1, a unit has to be standardized. So what does that mean? If I tell you that this desk that I'm sitting at is 8 pencil lengths wide, that's not very helpful, right? How long is a pencil? Are all pencils the same length? I don't know. So a unit has to be standardized. 2, a unit has to be understood by the intended audience. In atomic physics, there's a unit called a megabarn. It's a unit of area. Now, if I'm talking to an atomic physicist, then a megabarn is a perfectly appropriate unit of measure for area. But if I'm talking to a realtor about the square footage of a house, then a megabarn won't be a very good unit. So I want a unit that's understood by the people I'm communicating this to. 3, I need this to be appropriate scale. What's that mean? I could say, you might say that you are 0.001 miles tall for the Ted Lasso fans. It might even be true, but it's not very helpful. You want a scale for the unit that's appropriate to what it is that you're measuring. In this course, we'll generally use SI units. SI units, this is the international system, but it's French, so it's really Système International. It's an extension of the metric system, so it includes the metric system and then a couple other units for some different things that we'll do later on. The units that we'll come across most in this course are, for length, we will use the meter. That gets a lowercase m. This is just over 3 feet long. For mass, we're going to use the kilogram. That is kg. And that's about 2.2 pounds, kind of. We'll talk more about that later when we get to force. For right now, it's a pretty good idea. And then for time, we're going to use seconds, which get officially a lowercase letter s. I will a lot of times use SEC just because a lowercase s when writing fast starts to look a little bit like a 5, and I don't want to mess around with that. In Physics 2, we'll add some extra units for electrical and magnetic quantities, things like that, but for now this is pretty much all we need. So that's units. Next up, we're going to need numbers. So we are going to use a lot of numbers in this course. We're going to use positives, negatives, 0, which is a lot more often than you might think. We use fractions and decimals. All I'm saying is be ready. A lot of times it's a good idea to wait to plug numbers in until the end of a problem, but I'll show you more on that when we get there. For right now, just know that we're going to use a lot of numbers. And then the last piece is scientific notation. So scientific notation is a convenient way to express really big or really small numbers. If I gave you a number like this, you'd have to spend a moment counting out some zeros. So instead, we take that same number and express it as a single digit before the decimal, and then an indication of how far we have to move the decimal to create that same number. So what I'm saying is this: I've got a 2 right now, followed by 9 zeros. So I'm going to put a decimal somewhere in this. I'm going to put a decimal right here, and I want to put it in a location that makes it so that I have exactly one digit before the decimal. So I put the decimal here. When I do that, I've changed the number. This is now a very different number, so I'm going to have to move the decimal back to get it into the right spot. I'm going to write how far I have to move it to do that. So I've got it here. I have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So I'm going to write this number as 2, because that's where the decimal is, times 10 to the 9th power. The 2 is indicating what kind of the value of the number is, and then the 10 to the 9th, this is what we end up calling the order of magnitude. So this is a 2 with an order of magnitude of 10 to the 9th, 2 billion. I'm going to do a couple more of these. So maybe I've got a number like this, 2, 4, 8, 0, 0, 0, 0. I'm going to put a decimal in the location that makes my number be between 1 and 10. So I have one spot before the decimal, which is right here. .48. I'm not going to write trailing zeros on this one. And then I have to move the decimal back to where it was, or write how far it would take to do that. 1, 2, 3, 4, 5, 6. I'm going to move it 6 places, so I'm going to say times 10 to the power of 6. I did put up a couple of practice tools for you in the lesson doc. If you are not comfortable with this right away, then take a moment and run through those and give it a shot. The same works for really small numbers. So maybe I've got a number like this. I'm going to do the same thing I did before. So I'm going to stick the decimal. I'm going to put in a decimal in the location that gives me one digit before the decimal. So that's going to be right here. When I do that, I'm going to get the 3.801. I'm going to have times 10 to a power. I had to move the decimal to get it back to where it was. 1, 2, 3, 4, 5 spots. I'm going to have a -5, and it's negative because the decimal moves to the left. So an easy way to remember that is if I've got a number in scientific notation and I have a positive exponent, that tells me that my number is greater than 1. Positive exponent. Number is greater than 1. If I've got a negative exponent, that tells me my number is smaller than 1. Because there's always someone. If I don't have to move the decimal at all, so if I've got a number like 5.87 and I really want to write this in scientific notation, I'm going to put the decimal in the right location, which is where it is already. And I'm going to say times 10 to the 0 because I didn't move my decimal at all. I wouldn't write this number in scientific notation anyway, but if I really needed to, that's what that would be. So that is units, numbers, and scientific notation. Give the practice tools a shot and make sure you are comfortable with this.